So for this lesson, we're going to talk about Pythagorean Theorem. So Pythagoras was an old guy who's given credit with discovering this right triangle relationship. And that right triangle relationship is this, that in a right triangle, so this box indicates that's a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So let's go and look at the hypotenuse. So I was always taught that the right angle points at the hypotenuse. So this is called the hypotenuse. It's the longest leg of a right triangle. And then these are the legs of the triangle. So A and B are in this picture and usually are labeled legs. So what the Pythagorean theorem says is that leg squared plus leg squared equals the hypotenuse squared. And I'll abbreviate the hypotenuse here. So in letters, in looking at this picture, the way we would translate that is it's usually a squared plus b squared is equal to c squared. Although these letters are arbitrary. They could be X and Y and R, like in a pre-calc class, or they could be L, K, and Z. They don't have to be anything. It's just that the hypotenuse squared, and do that, the hypotenuse squared is equal to the sum of the legs squared. And you can remember it's a leg because a leg is like a letter L. So it makes an L. So the legs form the L. So let's look at a couple of examples. So in this first example, have drawn a right triangle. This is the little box that indicates it's a right triangle. And we're going to use the Pythagorean theorem to find this missing hypotenuse. I have a leg of 6 and a leg that's 8. So the first thing we do is write down the formula. So that would be a squared plus b squared is equal to c squared. So this is the hypotenuse. So this is always going to be the hypotenuse. Whatever letter this happens to be, this is the hypotenuse. So let's make our substitutions. Also, it doesn't matter which leg we call A and which one we call B, because we're going to square them each and then add them. And multiplication and addition are both commutative, so it doesn't really matter. So just to stay consistent, I'll call the short leg A, so 6 squared, and the long leg B, which is 8 squared, and this is equal to c squared. So then we just go through and we do our arithmetic. 6 squared is 36, 8 squared is 64, and this is equal to c squared. And then I will add these two numbers together, and that equals 100. So c squared equals 100. So I have to take the square root of both sides of this equation, and the square root of 100 is 10. So that is our final answer, that the hypotenuse that we were looking for is 10. So here's another example. Have a right triangle here. One leg is labeled 4 and the other leg is labeled T. So remember the legs are at the L. So that means that this number 7 would have to be the hypotenuse. So let's go ahead and just write the formula. A squared, whoops, I want to switch colors. A squared plus B squared is equal to c squared. So the short leg is 4 squared, and the longer leg is right here. So notice that's not a B or an A, it's a T. So I can have a different letter. So 4 squared plus t squared is equal to the hypotenuse 7 squared. So remember the hypotenuse is across from the right angle. The right angle points at the hypotenuse. Sometimes I even draw an arrow in like that. So I'm going to go back over here to my equation and start to simplify things. So 4 squared is 16, and 7 squared is 49. And then when I subtract 16 on both sides of this equation, I get 33. So when I take the square root of both sides, I get that t is equal to the square root of 33. Now this is an irrational number, so quite often people will simplify this and just use a calculator to do this, but that would be about 5.7. So my final answer is that this missing leg t, which is up here, that's 5.7 approximately, or the square root of 33 exactly. So here's another right triangle. There's my right angle. That makes this a hypotenuse. So I have one leg that's 5 and a missing leg, we labeled k this time, that we're going to be looking for. So go ahead, start with your formula. A squared plus b squared is equal to c squared. And let's see, the short leg looks like it's 5 squared, and I'll call the other leg k, so k squared. And that's equal to, now notice this is the square root of 61. So I need to square that as well. So going through and doing some simplification, we get that 25 plus k squared is equal to 61. Because the square root of a number squared, so I'm taking the square root of 61 and squaring it, equals the number. So going back, I have k squared. If I subtract 25 from 61, I get a 36. So this does have a perfect square. So when I take the square root of each side, I get k equals a square root of 36, or k equals 6. So there is our solution to this one. So here, previously we had an answer that was a square root, but on this one, we started with a square root. So it doesn't matter, it's just this will always hold, as long as it's a right triangle with two legs that form an L. So here's our fourth example. We have another right triangle. This time we just changed the letters up again just to keep it interesting. But I have a leg squared, a leg, and another leg, 12. So 8 squared plus 12 squared should equal m squared because m is the hypotenuse. The hypotenuse is the longest side and it's always across from the right angle. So let's go ahead and write our formula. A squared plus b squared is equal to c squared. And I guess 8 is my short side. I don't have to make a my short side, I'm just doing that. I could have written it the other way. I could have written 12 squared plus 8 squared. Doesn't matter. And I'm going to be looking for m. So leg squared plus leg squared equals hypotenuse squared. So let's go ahead and do some simplification here. I have 64 plus 144 is 12 squared. And that is equal to m squared. And then let's add these two numbers together and get 208. So that's not a perfect square. So I'm going to take the square root of both sides. So that is, m is the square root of 208, which simplifies because 208 is the same as 16 times 13. So that means the square root of 208 is square root of 16 times the square root of 13. And the reason we do this is so we can extract this perfect square. So the square root of 16 is 4, and the square root of 13 does not simplify. So this is all equal to m. And if we wanted to simplify that, we could type it in a calculator. 4 times the square root of 13 is 14.4. So however many units that is, inches, centimeters, something. So the final answer here is, let me do a box around this for us. So there you have it. That's the Pythagorean Theorem. There's 4 quick examples. Feel free to stop and go back as many times as you want to. But this is a very basic thing. I think it's originally taught in pre-algebra, but we do it a lot in geometry, and it's even used in algebra, algebra 2, pre-calculus, trigonometry, the whole 9 yards.